Okay, today we're going over 12.5, working with samples. So let's first go over a couple things here. A sample gathers information from a part of the population. And the sample proportion is the ratio of number of times an event occurs in a sample size. So you're going to have x over n, where x is the number of times the event occurs and n is the sample size. So we obviously want to have n be a pretty big number. The bigger the number n is, then the more reliable that this will actually be. Okay, so it says finding the sample proportion. So it says in a sample of 350 teenagers, 294 have never made a snowman. We need to find the sample proportion for those who have never made a snowman. Write the answer as a percent. So we have 294. That will be in the numerator, 294. We're going to divide that by 350 and then see what we get. So 294 divided by 350 is 0.84, which is 84%. So 84% of teenagers have never made a snowman. And this problem here, it will really vary depending on what your sample, who you're sampling and who you're going to be asking this to. Because if you ask people, teenagers on, say, Maui, then this is probably pretty accurate. But then if you ask somebody more on the east coast of the US, that's probably not going to be as accurate. So if you're going to be comparing these from Maui teenagers to, say, New York teenagers, you're going to get something that's pretty biased. Okay, so that means that you're going to want to have a random sample. So in a random sample, all members of the population are equally likely to be chosen. And when a part of a population is overrepresented or underrepresented in a sample, the sample is biased. Just like what we talked about for the Maui teenagers versus the New York teenagers, it's going to be biased if we ask one over the other. So let's take a look here to see if any of these are biased and why. It says a news program reports on a proposed school dress code. The purpose of the program is to find out what percent of the population in its viewing area favors the dress code. Identify any bias in each sampling method. So it's not just saying that they're asking just the students at the school, it's saying overall. So it's just talking about the population in general, not specific people. So the first one is viewers are invited to call the program and express their preference. And we want to say if this is biased or not. So this first one here, this one is biased. And it's biased because it's only going to be getting the people that actually call the program. Maybe they're calling in because they really care about this dress code, and that's why they're calling in. Okay, so you also have to identify why it's biased. Part B is a reporter interviews people on the street near the local high school. So if they're just asking people that are near the local high school, then maybe you're only going to get the high school kids, and maybe you're not going to get their families. And this is more, this is also biased, and that's mainly because this one is out of convenience. So they're only asking the people that it's going to be convenient for. Part C is during the program, 300 people are selected at random from the viewing area. Then each person is contacted. So since they're saying that they're selected at random, this is going to be our best choice here, because then they select the people at random and then those people are going to be contacted. So this is our best option here. Okay, so like we said before, the size of a sample affects its reliability. So with the small sample size, you're likely to get a wide range, more variation of sample proportions. With a large sample size, it will show less variation. So it's You can also kind of think of this as kind of like your test scores. If you notice, when I first put into Jupiter Grades your one quiz or one homework assignment, that's going to really affect your grade. But then as we have more homeworks and more quizzes in Jupiter Grades, each one is going to affect it less. So you can think of it more like that. Okay, let's talk about now the margin of error. So the margin of error is, we're talking about something where if we have a sample proportion, should be reported with an estimate of error called the margin of error. So if we're talking about something where we're talking about an election and the number of votes people get, things like that, then you'll probably hear that they have a margin of error of plus and minus a certain percentage. So when a random sample of size n is taken from a large population, the sample proportion has a margin of error of the following: plus and minus 1 divided by the square root of n, where n is the sample size. Okay, so if we take a look here, it says a poll reports that 56% of voters favor candidate B with the margin of error of 3%. Estimate the number of voters in the poll. So we can first say that we can find the interval of what it actually was. So if we have 56, they're saying 56% of voters favor candidate B, we have to actually estimate in the margin of error. So you would actually go ahead and add and subtract 3%. So 56 plus 3, 59%, and 56 minus 3, 53%. And then you would actually get the interval that will be telling us the sample of this. So it's the likely range for the true population proportion is actually 53% to 59%. So now we can actually look to see how many people voted. So if we know that the margin of error, MOE for margin of error, is equal to plus and minus 1 over the square root of n, then they just told us that the margin of error is plus or minus 3%, and then we'll solve for that. So we have 1 over square root of n. 3% is plus or minus 0.03. Okay, and then we can multiply both sides by the square root of n, dropping our pluses and minuses. We know that n is going to have to be positive anyways, right? So we have 0.03 times the square root of n is equal to 1, dividing both sides by 0.03, just to show all the steps. We get the square root of n is equal to 1 over 0.03, and then we can square both sides here. So n is about, I'm just going to plug this into my calculator, 1 divided by 0.03 is 33 1/3. I'm going to square that, and I'm going to get it to be about 1,111 voters. Okay, let's try one more here. It says a survey of 2,580 students found that 9% are left-handed. So we want to first find the margin of error. So the margin of error we know is plus and minus 1 over the square root of n. And n in this case, this is what n is equal to. 2580 is 2580 here. So I'm going to go ahead and put that in. The square root of 2580. And then 1 divided by that answer will give us about plus and minus 0.01969. 0.19687, which we can say that is about plus and minus 0.02, which is about plus and minus 2%. So that's our margin of error right here. Oops. And now we're going to use the margin of error to find the interval that is likely to contain the true population of left-handed students here. So we're going to take, they told us that 9% are left-handed. So we're going to take that 9% 9%. And we're going to add and subtract 2% from that. 9% minus 2% is 7%. 9% plus 2% is 11%. And this is going to be the interval that is likely to contain the true population proportion. And that will wrap up 12.5, working with samples. Thanks for listening. Bye-bye.